Today we will talk about radical expressions. The symbol, which you see here, is called a radical. A radical does the opposite of what a power or an exponent does. For instance, 4 to the second power is equal to 16. But when you take the square root of 16, you get 4. 5 to the third power is 125. If we take the cube root of 125, we get the 5. When you see a radical expression, the n is called the index or the root. The a, the number under the radical, is called the radicand. To find the root of a number, find the number raised to the given root equal to the number under the radical. The even root of a negative number is not a real number. For instance, if I had the fourth root of negative 81, this number is not a real number, so there's nothing that we can do to show a real answer. The odd root of a negative number is a negative number. If we have the third root of negative 64, then the answer is negative 4. Remember, if you take the even root of a negative number, the number is undefined. To find the root of a variable, divide the exponent by the root. For instance, if we have the fifth root of m to the 10th power, we will take 10 and divide by 5 to get an answer of m to the second power. The answer is not under the radical. To find the root of a term, find the root of the number and the variable. So if I have the square root of 36x to the 8th power, remember, when you see the radical without a root, the root is automatically 2. The square root of 36 is 6. For the variable with an exponent of 8, I take 8, divide by 2, and I have an answer of x to the 4th for my variable. To multiply radical expressions with the same root, we'll multiply the inside parts, which are the radicads, together, and then we'll simplify the radical expression. To simplify a non-perfect square radical expression, we'll find the largest perfect square that will divide evenly into the radicad. Then we will rewrite the radicad as a product of the perfect square. Finally, we'll take the root of the perfect square, leaving the other factor underneath the radical. For instance, if we have the square root of 45, 45 is not a perfect square. The perfect square factor in the number 45 is 9, so we change the square root of 45 into the square root of 9 times 5. Then we take the square root of 9. The square root of 9 is 3. We leave the factor of 5, underneath the radical. The square root of 45 simplified is 3 times the square root of 5. Our next example is the square root of x to the 9th. Remember, we don't see our index with this radical, so the index is automatically 2. Because the index is 2, an even number, we will want to find the highest even exponent that we can use in x to the 9th. So we have the square root of x to the 8th times x to the 1st. Remember, we're taking the square root of an exponent. This will be different from taking the square root of a number. When we take the square root of an exponent, we'll divide the exponent by the index. So here we'll divide 8 by 2, and we'll have an answer of x to the 4th. X to the 4th is not under the radical, but we leave the square root of x as it is. Let's take a look at an example. In our example here, we're to simplify the square root of 6a squared b to the 3rd times 8a to the 5th b to the 7th. So the first thing we're going to do is check our index to make sure that they're both the same. So here we don't see the index, so the index is automatically 2 for both of the radical expressions. So then we can multiply what's underneath. 6 times 8 gives us 48. 8 to the second times 8 to the fifth. We will keep our base, add the exponents. This is 8 to the seventh. B to the third times B to the seventh. Keep the base, add the exponents. 3 plus 7 gives us 10. So now that we've multiplied all of our expressions together, we can now simplify. 48 is not a perfect square, so we have to think of the largest perfect square that we have in the number 48. The largest perfect square is 16. 16 times 3 is 48. Remember, our index is 2, so we have to find the largest even number for the variable a. So we'll have a to the 6th times a to the 1st. B to the 10th is an even number, so we can leave b to the 10th as it is. Now we'll take the square root of our perfect squares. The square root of 16 is 4. The square root of a to the 6th, I take 6, divide by 2, I have a to the 3rd. The square root of b to the 10th, 10 divided by 2 is b to the 5th. I leave everything else under the radical. Therefore, under the radical, I have 3 a to the 1st. So our final answer, simplified, is 4 a to the 3rd b to the 5th times the square root of 3a.